In 2004, historic wildfires created a cloak of smoke over Alaskan forests. As the climate has warmed, such fires have gotten worse. In Alaska, where spruce trees have fed hungry flames for thousands of years, large blazes nearly doubled on average from the 1960s until 2015. These fires unlock the soil's carbon stores and release them into the atmosphere. Theoretically, that carbon can lead to long-term warming and even more fires. Yet new research offers a glimmer of hope. It suggests that when spruce trees die, the trees that replace them, leafy birch and aspen, may curb wildfires and slow carbon leakage from their habitat. The 2004 fires scorched 7 times the 50-year average land area for Alaskan burns. This created a vast natural laboratory for ecologists who study forests. They knew that deciduous trees, such as birch and aspen, tended to sprout up in the embers of burned-out coniferous spruces. But they needed to know more about this transition to understand how the climate and ecosystem might change over a long time, say a century. From 2005 to 2017, researchers scoured 75 sites where spruce dominated before the 2004 fires. They estimated the total amount of seedlings from species of spruce, birch, and aspen to determine how the sites transitioned. By 2017, only 28% of the sites returned to spruce dominance. 72% became either a mix of spruce and deciduous or deciduous dominated. The researchers measured tree diameters to estimate the amount of carbon and nitrogen stored above ground. They also estimated the amount of carbon and nitrogen trapped in the soil. To do this, they compared the depths of burned, formerly carbon-rich soil layers to those of new layers and measured the heights of roots disturbed by the fires. But they still needed more data to forecast forest turnover. The researchers panned detailed Alaskan forest fire records dating to the 1940s, and identified burn sites once dominated by spruce, now in different stages of transition. They traveled to the sites to collect data, then combined them with data from the 2004 burn sites. The combined data helped them estimate forest trajectories over 100 years. This showed forests that transitioned to birch and aspen would accumulate carbon 4 times faster than forests dominated by black spruce. Most carbon would be in the trees themselves, since deciduous trees gobble up soil nutrients as they grow rapidly. Spruce trees grow slow and steady, leaving a wealth of organic soil that readily ignites. The live fast, die young approach of aspen and birch leaves less fuel for wildfires to chew up and spit out into the atmosphere as carbon dioxide. Deciduous trees are set to dominate the interior Alaskan forests by the end of this century. Still unknown is whether birch and aspen forests will stave off wildfires as the region becomes warmer, since just about anything can burn in very dry, hot weather. If this forest turnover does lead to a less fiery Alaskan landscape, carbon may continue to pool amid the shady canopy of the Great North's future forests.